And we are live. Hello, everyone. Welcome. My name is Britt Mulder. I'm the marketing manager at Eatron Technologies. We are very excited that you're here with us today for our 11th Talk to an Expert. Talk to an Expert happens live every last Thursday of each calendar month at 4 p.m. UK time. In case you miss any of them, they're available on Spotify, YouTube, and on our website. A bit background about us if you don't know us. So, Eatron is an international technology scale up dedicated to making software defined vehicles a reality for OEMs worldwide. Our house rules are if you have any questions at any point of this talk, please put them in the comments, and our guest of today will answer them at the very end. So, today we have Yogesh, who's our Vice President in India. Hi, can you please tell us a bit more about yourself?
Hi, Reid. Hi, everyone. It's really great and pleasure to be part of these sessions. My name is Yogesh Umbarkar. I'm a mechanical engineer by profession, but then I've started my journey right from the powertrain design development. Both started with the conventional to the electric vehicle, and before joining Eatron, I was responsible for Ricardo's software and application engineering business in Asia, where I've helped the companies, particularly OEM and the tier one, to improve their powertrain performance through the simulations. So I've been more of automotive guy, started from the technical management to the techno-commercial management. And then last Valentine or the on the 14th Feb, the Valentine Day, that's where I started my journey with Eatron. And I think it was really one of the most fantastic experience uh, in terms of dealing with a diverse set of both the Indian as well as I would say the European, Turkish kind of environment where one is a cultural, but then also in the EV ecosystem, I've been able to connect not just the OEM and tier ones, but also a lot of semiconductor guys, the EMS guys, the control development guys. And I think it has been a very exciting, very learning and value added journey for me. And yeah, I'm happy to share my experience in terms of how in the Indian ecosystem, the various players got various challenges, and then how the technologies are evolving and what kind of a technologies are helping them in principle.
Cool.
So
Thank
great to be part.
Thank you. Um, thank you for joining us. It's great to get an insight of your experience in the Indian EV ecosystem, particularly in the electrification area. So we see that two three-wheelers have an exponential growth. So let's dive in. Can you tell us how swappable batteries are helping to accelerate this two three-wheeler adoption?
Yeah, I think it's a really good question because now this is really one of the key topic which is coming across the EV ecosystem, guys. And then there is a lot of debates are happening in terms of uh, particularly it should be a fixed battery approach or swappable battery option. But let's look at to address why swappable batteries are helping. I think we need to see that what are the key issues related to adopting this electric vehicle. I think one of the key quick thing comes up the upfront cost, right? So when you look at the beyond the we talk about a climate change and supporting the pollution free environment, transportation or mobility. I think one of the consumer mind looks at the total cost of ownership, and within that total cost of ownership there's a upfront cost, the operating cost, and then the maintenance cost for a lifetime. And within that, the upfront cost is really one of the key challenge to go over the electric vehicle because the battery cost is substantial. And then if you compare the IC driven versus the battery driven, the upfront cost is still 30 to 40% more than your conventional powertrain vehicle. And hence, one is that upfront cost. The second one is the charging infrastructure, particularly in the two three wheeler. Is if you see the numbers of the kind of users or consumers, they have it in India. they don't have a lot of charging infrastructure because everybody stay mostly in the multi-story buildings where there's no parking or charging infrastructure available. And the third challenge is the charging times associated. Everybody know I can go to the petrol or gasoline pump and then quickly fill it in the minute, whereas I don't have a time to wait for 20 minutes or 30 minutes to charge my batteries, because that kind of reduces my efficiency, and particularly not for just consumers like you and me, but also the e-commerce. Like there are fleet owners who run the two-wheeler kind of a fleet for a food delivery or e-commerce. So for them, these are the big challenges, and where the swapping is really one of the key option where you can quickly the manufacturers can kind of sell only the vehicle and they can provide battery as a service, so reducing the upfront cost for the users. Next thing is you can quickly replace your discharge battery with a charge battery, so it reduces your charging time related issues. And I think the most important is the consumer don't have to worry about the charging discharging related time, but also the life related issues, because if the battery is going to die within 3 years instead of 5 years, he's going to go into substantial cost, so he don't get rid of that. And at the same time the manufacturers can generate a revenue offering this service, so it's a kind of a win-win approach both for consumer, manufacturer, and hence it is really one of the low cost quick solution accelerating this adoption of the electric vehicle in principle.
Thank you. So could you tell us a bit more about the key technical challenges associated with battery swapping as a service?
Yeah, I think the opportunity is really great for the swapping, but as every opportunity comes with its own challenges. And then here, I think the if you look at the challenges, I'll try to term it into three terms: safety, performance, and the life. And out of that, obviously, let's talk about the safety. We've seen in India a lot of issues related to the fires, right? Where then the battery operator or the swappable guy is responsible, and it's a lot of things at stake, right? Just beyond the finance and economics part. Then the performance. Now, for example, these vehicles are used by, like, say, a normal user like me who go just use the electric vehicle for market and short distance. But then there could be a fleet users like food delivery guys or e-commerce where they have a time constraint to reach to the destination and deliver. So they do a lot of literally they kind of abuse the batteries with sudden acceleration and braking, right? And hence the life of those battery get asset reduced. Whereas this battery is asset for those battery swappable guys, and they see that okay, their whole business economics is associated with how long I can use that asset, right? Otherwise, if he's instead of 5 year where he has set up his economics on the basis like battery is going to survive for 5 years, but if he's going to die in 3 years, he has a lot of issues of his business viability. I mean, and that is a challenge with both finances, insurance, and so on. And the third aspect is the performance also, because at the end of the day, how I can improve the performance, because with one charge, if I can give better mileage or better range, then I have a more operational efficiency and operational economic turnout beyond that. So this, I think, overall with the safety, the performance, and the life, these are the key critical challenges where they are still trying to figure it out how we can improve the safety, performance, and the life of the batteries. And I believe everybody is looking at much more better solutions to make it a sustainable and economical viability for them in terms of the swappable batteries.
Thank you. Well, it's interesting to see the challenges that you've just mentioned. Could you then tell us a bit more about the solutions to these challenges, and maybe more specifically how are intelligent AI-based BMS solutions helping battery swapping players?
Yeah, I think again to address this kind of a question, I think one of the key thing is uh, again linking with the safety, the life related issues or the performance related issues. I would probably like to give certain examples. So for all these things, if you can analyze the batteries, ultimately battery as an asset, if you are able to analyze how that batteries are performing in the real world, right? And if you can track and monitor its performance in terms of current, voltage, temperatures, you are able to take a more preventive actions much in advance. For example, uh, the sales typically the impedance kind of a thing behavior changes, and then you can see that particular sale as compared to the normal sale. If certain sale is going to have a certain failure issues, it will start show some odd behavior well in advance, so that you can then predict that this particular sale is going to fail or going to cause the fire related issues. So then you can take this corrective action using this sale prognostic, and then AI really can help you to build that kind of predictive models and kind of accurately give you the warning and hence prevent that failure or safety related issues. So that's one sale prognostic using AI is really one of the key solution. The other solution is on the life is the remaining useful life, right? So
Mhm.
typically we have seen a very common term everywhere is a SOS, which is a state of health. But for a battery lifetime, at any given point of the time, we say that okay, this is my SOH, okay. But then that SOH is a past data where I know how much the battery has degraded, but I don't know to my useful life how long that battery is going to survive. And as I said earlier, if these battery swappable guys, they can evaluate whether, given the duty profile of that e-commerce or food delivery guy, if he's continue abusing it, if the
Mm.
battery is going to die in 3 years instead of 5 years, I'll have a
Mhm.
issues. So now I need to take corrective action. So then this AI can predict the remaining useful life, and then you can say that okay, this is how the behavior, and if this guy continue abusing my batteries, I'm going to end up into my economical or business issues. So now I can take corrective action in terms of limiting the certain power windows or SOC windows, so that the the consumer, that Swiggy driver, won't be able to abuse it because he's keeping that control. The BMS can keep that limitations there, and
Mhm.
hence you can improve your remaining useful life. So there are a lot of such AI techniques available where you can do the better analytics and prevent the safety issues. You can improve the remaining useful life of the batteries and also the performance of the batteries, because you can check whether it's operating in the high environment, and you can kind of calibrate the performance, and over there you can send update to say that hey, try to tune your behavior for this kind of a temperature environment or this kind of abuse environments. So
Mhm.
yeah, I think that's ultimately AI offers a great solutions to improve the battery life, to give better warnings, and I think it's a more economical, sustainable solution.
Thank you. Thank you so much for answering the questions and bringing light to this topic. We've asked a couple of Etronians to ask some questions to get people to fire up theirs. So let's start with Mukait's question. Says, "Hi, thank you for the event. What are the hardware aspects which needs to be considered from AI BMS, or how much hardware plays a role, especially for remaining useful life? You will need to process a lot of time series data through AI."
Yeah, I think it's really the great question, because I think immediately the question which has popped that comes into the mind when you talk about AI, it means all data driven models, and the data is a lot of data, and particularly if you look at the kind of a data which is get generated by the each vehicle per second or per minute is huge. And to predict, for example, any remaining useful life, you need to process a lot of data, which is and then to process that data means, now if you want to have a more efficient kind of a processing where it gives a faster processing, it gives a quick response, and it doesn't consume a lot of power, then that hardware need to be equipped well. So now, if you see that earlier we had a normal, just like laptops, we have a CPUs. Then we moved to the GPUs, which are more used in the cloud, and now we see that there are more AI specific hardware are developed. So they call it as AI accelerators. So like it's much more of field programmable gate arrays, FPGAs, or ASIC kind of a things which are getting developed and which are dedicatedly used for processing the AI models. And hence, the efficiency, the faster processing, ultra low power consumptions are being worked out in principle. So I think hardware plays a key role. And recently, just to give you the insights, like we have recently announced our partnership with also Cynthian. So Cynthian is the one of the neural network AI accelerator chip, which is very small and tiny, which is very ultra faster. It consumes very less power, and its processing speed is very higher compared to any other chip makers. And we have been able to showcase how our AI cell prognostic or remaining useful or SOH models are performing the best using this chip. So, and I'm happy to share more details if somebody is interested in this Cynthia and our partnership solution.
Thank you. Brian is asking, what is saying, great to hear your views, Yogesh. Can you explain the deployment flexibility of Eatron's BMS hardware?
Oh yeah, I think so. I think this. I think this is another linked question where you talk about, okay, you've got a software, but then you can deploy it either on the edge, which is more on your BMS board, or you can deploy it on the cloud as well. I think the answer lies with Eatron. We see that what kind of a processing can fit better on the edge, and what kind of a things fit better on the cloud, because we need to optimize the edge versus cloud computing, because we cannot put all the processing on the cloud, because both your communication cost, your cloud infrastructure, plus your delays might be there. So whereas we cannot put everything on the edge also, so we try to make the best combination of that hybrid deployment, where let's say 80% we try to do it on the edge, particularly on the two three wheeler. The kind of a thought process is 80 to 90% or even more data can be processed on the edge chip using the Cynthian NDP-120, and then only certain data which is required for the user or a battery pack guy to see, that can be managed to deploy on the cloud through the
Mhm.
dashboard and so on. So I think we have both the flexibility in principle, but we optimize the solution of edge and cloud deployments.
Thank you. Sai, I hope I'm saying your name right. I'm sorry if I'm not. Sai's asking, thanks for the points, Yogesh. My question is how cloud-based battery analytics is going to play a role in the India EV market.
Okay. I think there are two things here. One is when you talk about a cloud, the purpose could be for the vehicle operational analytics, and the second one could be your the performance analytics, the way we were talking about. And here, I'm more talking on the cloud for your uh, battery performance optimization or battery life optimization related things. And here in India, the I think the cloud cost, if you look at a two three wheeler,
Mm-hmm.
the user or the consumer of this two three wheeler, they're not even willing to pay $1 a month. Okay. And if you look at, if you want to project or if you want to do a lot of AI processing on the cloud, this cost will be very high. Okay. So that means that business economics is going to be a very big challenging factor in cloud implementations. And that's where we see that, particularly for the two three wheeler, the age computing, or the when we have worked out with Cynthia and the NDP 120, is the age solution will be much more economical, much more efficient in the two three wheeler segment in India particularly. So yeah, I think I hope that answers. So the more I would say the deployment viability is towards the edge rather than on the cloud in India, particularly in the two three wheeler segment, because it's quite cost sensitive segment, and I think the cloud communication cost, the cloud infrastructure, storage, data transfer speed, and even the network connectivity, those are the big challenges in India, which doesn't support much of the cloud.
Thank you. Annette, another Ukrainian, is asking, thank you for this insight, Yogesh. Can you further explain, please, what the advantages of an AI accelerator are?
Yeah, I think just as I mentioned earlier, typically uh, when you talk about a AI accelerator, uh, the the key thing we look at here is this processing speed and the time required to have a response with the different component on the BMS or with the battery or with the vehicle. So it's processing speed, it's response time, and also the cost associated with the AI accelerator as compared to the normal macros. I think these are the key benefit. Beyond the, it reduces your cloud communication cost, the way I was mentioning it, and also the infrastructure requirement for the cloud base. So I think the advantage are in terms of the faster speed, the response time, the low power consumption, the reducing the cost of clouds basically or communications. These are the key advantages which I can see.
Thank you. So we've got Emre who's asking a couple of questions. Thank you for the event. My question is, did you ever consider creating simulations that are based on your AI models? If so, do you think selling simulations would have a good market?
Yeah, I think definitely there are both the things. I mean, if I understand his question correctly, let me just frame it. Okay, so he's trying to compare the selling simulation would be a good market rather than creating simulations that are used on AI models. Okay, so just to reframe that, let me correct if my understanding is correct, and if you can answer yes, then I can respond. So he's trying to say that uh, instead of the creating simulations that are based on the AI model, that's a one thing. He can
Mhm.
probably sell directly the simulations offline. Is that, if it is the question? I think my response would be yes, the selling simulation would really help. But I think when you talk about a remaining useful life or even the sale prognostic, it requires a lot of data, and you need a live uh, you need to track the real world performance data to be able to predict its either failure issues or it to predict accurately the RUL. So I would say that the live real world AI modeling is going to help a lot, and that is the way forward we see.
He said yes, by the way, so you're answering you're answering the correct question.
Okay.
Um, Emma actually sent through another question. How can you model? No, sorry. How can your model cope with inexpensive embedded system solutions that already exist in the market and already have high accuracy?
Go with inexpensive embedded system solution. Okay, so I think if he's referring to inexpensive embedded solution like the CPUs or the standard macros from the, let's say, standard in semiconductor companies like Infineon, Renesas, or a few others, whatever. I think our solution is, I would say there are two factors. I mean, and again, when you say about uh, the our solution in terms of the Cynthian based approach, if it is that reference, I would say here the cost is very less compared to the normal macro. The second one is it's the analytics or the AI analytics based on that chip is much more accurate. So anything you compare is cost, accuracy, or quality, and even the time. So I typically use this time, cost, quality, and all those three matters. I think our solutions stand out very uniquely or very effectively. So I would say that in the Indian market where it's all value driven market and it's very price or cost sensitive market. So that's where I see that the Cynthia's based solution would be a really a great one. Given the kind of a solution we have developed with them, giving much more accurate solution and the cost is even much lesser than the standard embedded systems or macros.
Thank you. Thanks, Yogesh. I think we've gone through all the questions. If anyone who's watching still has a question that's firing up today or tomorrow, just add it in the comments, and then they will be answered in the comments. So, thank you very much for your time today. Oh, sorry. There's another question. Yogeshwar is asking, hey, thanks Yogesh for the wonderful insights. How many features or variables are being considered to predict such battery performance or useful battery life predictions? That
Okay, I
was right.
think okay. No, I think it's definitely a, a really a good question. The way I see that, I'm not a one of the AI developer, so I think the response might be very generic. Just to give the caveat here, but then I think the key message is the feature extraction is really one of our strength because we are coming from the automotive and the domain experience guys. So it's not just otherwise in most of the AI model, if you see that it's garbage in, garbage out kind of a thing. So you need to understand how you filter out the noise very effectively, or how you sanitize your data or input variables is a key to the output or accuracy of your AI models. So I think in terms of how many, I might not be the right person to kind of respond here, but I'll definitely come back to you, Yogeshwar, talking to our experts like AI developers, or I'll help you to connect with them so that you can get a better response from them.
Cool. Thank you so much. We have reached the end of our talk. So, thank you everyone who has tuned into our live today or who has come back to tune into our live. We hope to see you in our next one in December. So stay tuned for that. And thank you, Yogesh, for giving all your insights and expertise today.
It's my pleasure, and I really enjoyed it. Thanks everyone for all the great questions, and look forward to connect again with a different
Thank
topic, possibly.
you. Thank you. Bye.
Take care. Bye.